Welcome back to Geography Unpacked. Last lecture we have seen that the high water marks of classical geography. But now we are going to look at what happens when that knowledge hits a crossroad. In West, we enter a phase often called the Dark Ages, where the map starts to look very different, shifting from a scientific tool to a more spiritual, symbolic one. But while things were slowing down in Europe, they were exploding in the East. We will explore how the Arabic world didn't just keep the lights on for geography, but actually pushed it into a new dimension of travel and precision. As we move into the 5th century, we see a profound transformation in how the Western world organized its knowledge. With the decline of Roman Empire, the vast trade networks and administrative structures that once demanded geographic precision began to fragment. In their place, we see the rise of a worldview where spiritual authority took precedence over empirical observations. During this period, the geographic horizon for most people contracted significantly. Science, as the Greeks has defined, didn't necessarily disappear, but its purpose shifted. The scriptures became the ultimate lens through which the physical world was interpreted. If a classical theory did not align with the theological truth, it was essentially set aside or heavily modified. This era is often characterized as dark age for scientific geography, but it's perhaps more accurate to see it as a period where the map was reimagined. The goal was no longer to measure the earth for navigation, but to represent it as a reflection of divine order. Instead of building on the mathematical rigor of Ptolemy, scholars worked to harmonize ancient concepts with the teachings of church, creating a geography that was more focused on the soul's journey than on the explorer's route on the map. As we enter the height of the Middle Ages, we see an interesting fusion of ancient science and medieval faith. Surprisingly, Ptolemy remained a dominant intellectual force, but primarily for his astronomy. His geocentric theory, the idea that Earth sits in motionless at the center of the universe, became the bedrock of the medieval worldview because it complemented the theological belief in man's central place in creation. However, when it came to actually drawing the world, we see the rise of TO maps. This is a fascinating departure from the grids of the Greeks. In the TO map, the O represents or the boundary of the world, surrounded by a massive circular ocean, while the T represents the water bodies. This is the T which represented the water bodies, usually the Mediterranean, the Nile, and Don, and divided the land into three continents: Asia, Europe, and Africa. That's most striking for us as modern geographers is the orientation. This map often oriented with east at the top towards the Garden of Eden. Most importantly, the center of the T, uh, which is this part, always contains Jerusalem. This wasn't an accident or a lack of skill. It was a deliberate choice. The map makers weren't trying to help you find your way from Paris to Rome. They were creating a visual document that prioritized spiritual truth over physical distance. In this framework, geography served as a canvas for the story of a humanity's salvation, where the location of a city mattered less than its place in the divine plan. While the TO map we just looked suggests a world turned inwards, history was about to force these horizons wide open. Between the 11th and the 13th century, the Crusades took place, and it took thousands of Europeans out of their isolated villages and pushed them into the heart of the Levant. While these were wars of religion, their byproduct was a massive geographical reawakening. We can't march across a continent and come back without becoming a student of geography by necessity. Through these encounters, Europeans were reintroduced to the real world, and they realized that while they had been focused on symbolic maps, the Arab world has been building a powerhouse of scientific inquiry. In centers like Baghdad and Cordova, scholars hadn't just kept the works of Ptolemy and Aristotle alive, they had been stress testing them. By the time the Crusades were winding down, the repository of knowledge held in the Islamic bag began to flow back into Europe. They brought with them refined instruments, more accurate calculation of the Earth's size, and a vastly larger view of Asia and Africa. In a way, the Crusades acted as a violent yet effective bridge that pulled Europe out of its dark age and back into the rigorous world of spatial and scientific knowledge. It reminds us that geography often advances the most when different cultures collide, even under the most difficult circumstances. Now we move into the important Arabic contributors to geography, starting with Al-Masudi. As we look at Al-Masudi, we see the true power of Arabic repository. He wasn't just a scholar sitting in a library, he was a traveler who used his own eyes to fact check the ancient Greek. While he respected the Greek tradition and firmly believed in a spherical earth, he wasn't afraid to tell Ptolemy he was wrong. One of his most significant breakthrough was his understanding of the Indian Ocean. You will remember that Ptolemy thought Indian Ocean was a landlocked sea. Al-Masudi, through his travels and talks with sailors, realized this was incorrect. He argued that it was actually connected to the Atlantic, effectively opening up the map and the potential for global maritime trade. He also applied his critical eye to the world's great river system. He debunked the popular myth that Indus and the Nile were connected, correctly pointing to the Abyssinian mountain, modern-day Ethiopia, as the true source of Nile's water. For those of you interested in meteorology, Al-Masudi was also one of the first to give us a clear scientific account of the monsoon, which were essential for the trade networks of Indian Ocean. Beyond the math and physics, Al-Masudi was a master of regional geography. He wrote vivid, reliable accounts of Persia, Syria, and Central Asia. He didn't just give us coordinates, he gave us the portrait of the world as a living, breathing system of interconnected climates and culture. He represents that perfect moment where the Greek foundation was finally meeting real-world empirical data. If Al-Masudi was the traveler, Al-Biruni was the physicist. His output was staggering. He wrote 27 books specifically on geography, covering everything from the math of mapmaking to the patterns of weather. But it didn't stop there. His work, Qanun al-Masudi, remains a masterpiece of astronomy, offering incredibly precise explanation for solar and lunar eclipses. One of the reasons Al-Biruni is so significant to our study is his deep focus on the Indian subcontinent. In his work Kitab al-Hind, he provides what is arguably the most accurate geographical account of India from that era. He wasn't just looking at locations, he was looking at processes. He was the first to realize that the vast Indo-Gangetic plain wasn't just always there. He correctly deduced it was formed by river silt brought down from the mountain. He was also one of the few scholars of his time to accurately describe the scale and impact of Himalayan ranges. Perhaps his most impressive feat was his work in geodesy. Using a mountain in what is now Pakistan and some remarkably clever trigonometry, he calculated the circumference of the earth to within 1% of its actual value. He used this precision to define the boundaries of the habitable world, moving us away from guesswork towards a truly measurable reality. He represents the peak of the Arab scientific geography, a figure who combined the logic of the Greeks with the rigorous modern observational method. Like Al-Masudi before him, Al-Idrisi was a corrector of ancient errors. He definitely rejected the Greek notion that the Indian Ocean was an enclosed landlocked sea. He also fixed the map of Caspian Sea, which has been inaccurately represented for centuries. However, his crowning achievement was the Tabula Rogeriana. This map was light years ahead of the TO maps being produced in the rest of the Europe at that time. It wasn't just a drawing, it was a 15 years research project. He followed the Greek traditions of dividing the world into 7 climate zones, but he filled those zones in with incredibly dense, reliable data about the people and land. For centuries, this map remained the most accurate representation of the world in existence. It proved that when you strip away the religious dogmas of time and focus on empirical evidence, the true shape of our world begins to emerge. Ibn Battuta was out on the road. He is arguably the greatest traveler of pre-modern world, covering a staggering 75,000 miles over 3 decades. His work, The Riyallah or The Travel, is much more than just a diary. It is a massive ethnographic and regional geography of the entire 14th century Muslim world and beyond. What makes Battuta so significant to our discussion of climate is his first-hand observation of equator. You will remember that for centuries the Greeks and even early medieval scholars assumed that equator was an uninhabitable furnace. Battuta actually went there and pointed out the paradox. The climate along the equator was actually less extreme and more habitable than the scorching temperate zones of North African desert. His writing wasn't just about distance, it was about the details of Earth. He gave us incredibly reliable accounts of different soil types, agricultural practices, and the economic structure of the places he visited, from the gold trades of West Africa to the island lives of Maldives. He moved geography away from the abstract and back into the realm of human experience. Through the Rihalla, the oikomen or habitable world wasn't just the circle on a map anymore. It was a complex interconnected reality of trade, politics, and varied environment. He provided the final human piece of the puzzle that Arabic world would eventually hand back to a reawakening Europe. As we conclude our look at the Arabic contribution, we meet Ibn Khaldun, a thinker who was centuries ahead of his time. His masterwork, the Muqaddimah, marks a turning point in the history of our discipline. While the geographers we have seen so far was obsessed with measuring the earth or mapping its coastline, Khaldun was interested in the relationship between land and the people who lived on it. He was essentially the first scholar to turn his attention specifically to the man-environment relationship. He argued that our physical surrounding, the climate, soil, the terrain, do more than just houses. They influence our characteristics, our culture, and our very way of living. But Khaldun was a nuanced thinker. He didn't believe humans were mere puppets of their environment. He balanced environmental influence with human culture, discussing how social organizations evolve and how governments are formed. He even went into the practical nitty-gritty of geography, analyzing the best location for cities and how different landscapes dictate the way people earn their living, whether through agriculture, trade, or craft. In many ways, Ibn Khaldun is the bridge to the modern social sciences. He taught us that geography isn't just a map of places, it's a map of human behavior and social progress. As the Arabic Golden Age begins to transition into the European Renaissance, it is this sophisticated understanding of human and regional geography that will eventually shape the 18th century thinker we will discuss on our coming lessons. As we conclude today's session, it is important to view the Middle Ages not as a global void but as a fascinating era of intellectual divergence. In Western Europe, geography underwent a transformation where its primary goal shifted from physical measurement to spiritual interpretation. The maps of this time were not intended for navigation but for contemplation, illustrating a worldview that prioritized sacred order over geometric precision. However, we have seen that while one tradition turned inwards, another was looking outward with unprecedented clarity. The Arabic world acted as a vital repository and a laboratory for geographical thought. Scholars like Al-Biruni and Al-Idrisi moved beyond the textbook knowledge of the Greeks, using advanced trigonometry and extensive travel to correct the maps of the world. They proved that Indian Ocean was an open highway and they documented the climate of equator with scientific accuracy. By the time we reach the socio-environmental theories of Ibn Khaldun, we see a discipline that has matured into a complex study of how humans and their landscapes interact. This vast body of knowledge, preserved and expanded in the East, eventually became the catalyst for European Renaissance. This brings us to the end of our discussion on the transition from medieval West to Islamic Golden Age. In our next session, we will continue this global journey by exploring the Chinese and Indian contribution to geography, looking at how the civilizations developed their own sophisticated system of cartography, navigation, and environmental thought. Thank you all for your attention today. If you have any questions about the scholars we covered or shift from the Dark Ages into the era of discovery, please feel to drop them in the comment box below and I'll be happy to address them. See you in the next lecture.